Hello guys, in previous class we have calculated the average voltage of EA at an angle alpha. No, so EA at an angle alpha we have calculated it, so it will be EA at an angle alpha, or I can also represent VA, that will be Vm by pi 1 plus cos alpha, Vm by pi 1 plus cos alpha, or I can also represent EA at an angle alpha is equal to Em by pi 1 plus cos alpha, Em by pi 1 plus cos alpha. So this I have represented here. The motor armature voltage of single phase semi converter will be EA at an angle alpha equal to Em by pi 1 plus cos alpha. This I can substitute in the speed equation. So as you know, the current equation EA equal to E at an angle alpha is equal to EB value I can substitute as EB equal to Ka pi into N. So I can substitute Ka pi into N plus IA RA. If I want to subject this speed equation, speed is equal to EA at an angle alpha minus IA RA by Ka pi. Whole term is divided with Ka pi. This is the speed equation. So for speed equation, speed is equal to EA at an angle alpha minus IA RA by Ka pi. This is the speed equation. In this speed equation, I want to substitute this EA value at an angle alpha. EA value at an angle alpha we have calculated, no, average value Em by pi 1 plus cos alpha. If I substitute this, speed equal to, this is the EA at an angle alpha term. So EA at an angle alpha minus IA RA by Ka pi. So if I divide these both terms, Em by pi 1 plus cos alpha by Ka pi minus IA RA by Ka pi. In this, if I substitute the torque equation value, as you know, torque is directly proportional to pi Ia. So if I substitute this torque is equal to pi Ia, if I remove this directly proportionality constant, torque equal to Ka pi into Ia. If I subject this Ia value is equal to T by Ka pi. So in terms of Ia, I have represented in the T by Ka pi. So if I represent here, the speed equation N is equal to Em by pi 1 plus cos alpha by Ka pi, this is one term, minus Ia RA by Ka pi, this is another term. In this term I want to substitute this Ia value as you know, T by Ka pi. So if I substitute this value, the speed equation will be Em by pi 1 plus cos alpha by Ka pi minus, in terms of Ia I have substituted the T by Ka pi, so T into RA by Ka pi into Ka pi, it will be Ka pi whole square. So this is the speed equation for separately excited motor semi converter. This is the speed equation. So this I have represented here. Speed equal to Em by pi 1 plus cos alpha by Ka pi is one term, and in terms of Ia value is T by Ka pi, no, T into RA by Ka pi into Ka pi, it will be Ka pi whole square. This is the value. So we have calculated the speed equation. Next we will move on to current equation. The current equation Ia equal to V minus EB by RA, no. So V minus EB by RA, we can represent V or VA or EA at an angle alpha. All these terms are equal. In different textbooks it will be represented in different terms, V or VA or EA at an angle alpha. So EA at an angle alpha we have calculated, no, it will be Vm by pi or Em by pi. So Vm by pi 1 plus cos alpha minus EB value as you know, no, EB equal to Ka pi into N. I can represent this Ka pi as constant Km. So Km into N, or I can also represent it omega m. So this value Vm by pi 1 plus cos alpha minus Km into omega m by Ra. This is the current equation. So we can represent the torque equation also. Torque equation T equal to Km into Ia. Ia value we have calculated, no, Vm by pi 1 plus cos alpha minus Km into omega m by Ra. So I can write T equal to Km into Ia. So this Ia value we have calculated, no. So Km into Vm by pi 1 plus cos alpha by Ra. This is one term, and Km into Km it will be Km square omega m by Ra. We can represent that omega m or n. We can represent anything. It is a rotational speed. So we have calculated the torque equation. Next we will move on to the armature voltage versus firing angle. So for these characteristics we have to calculate the VA value at an angle alpha value at an angle 0, as well as alpha value 90 degrees, as well as alpha value 180 degrees. So these three values we have to calculate it. So for these three values, first we will calculate VA at an angle 0. So VA alpha value at an angle 0, if I substitute the VA equal to Vm by pi 1 plus cos alpha. So in this alpha value 0 I am substituting it. So VA value equal to Vm by pi cos alpha value 0 means 1. So 1 plus 1 it will be 2 Vm. VA value will be 2 Vm by pi. So at an angle alpha value 0, the value of output voltage will be maximum, that is 2 Vm. And next we will calculate the alpha value 90 degrees. So VA equal to Vm by pi 1 plus cos 90 degrees. Cos 90 value will be 0, no? So VA equal to Vm by pi 1. So it will be Vm by pi only. So at 90 degrees the maximum value will be represented here. The value will be Vm. At 90 degrees the value will be Vm. And the final value VA equal to Vm by pi 1 plus cos 180. So cos 180 value is minus 1, no? So VA equal to Vm by pi into 1 minus 1, the value will be 0. So the value will be 0. So at 180 degrees the value will be 0. So I can represent that here. The VA value at an angle alpha equal to 0, the value will be 2 Vm. At 90 degrees it is Vm. At 180 degrees it will be 0. VA value will be 0. And this is a chart table. So for remembrance you can take this table. So for 0 it is 2 Vm, and 90 degrees it is Vm, and 180 degrees it is 0. So this is the armature voltage versus firing angle. Next, speed torque characteristics. As we have discussed earlier, the separately excited motor characteristics are drooping straight line characteristics. For speed and torque characteristics are drooping straight line. Drooping means decreasing straight line. So drooping straight line characteristics. Here also, while changing the firing angle from 0 to 90, the speed will be decreased. So I can represent this decreasing straight line. While changing the firing angle, the speed also decreases. So this can be represented with speed torque characteristics. So we have discussed the speed torque characteristics, armature voltage versus firing angle, as well as this is the torque equation. This is torque equation. In problems we will have this torque equation, and this is the current equation. Current equation. So the current equation will be Vm by pi 1 plus cos alpha minus Km omega m by Ra. This is the current equation and the torque equation. So we will meet in next class. Thank you guys.